Hello students, how are you? I hope you're all doing well. I'm your physics mentor Ankit Kumar Singh. I'm from Patna. I've done my BTech in electronics and electrical engineering from KIT University. After that, for the last 3 to 4 years, I have been teaching in various coaching institutions. Well, that is enough about me. So, we are going to begin our class with a very important and foundational chapter, that is motion. We use the word motion in our daily lives. For example, if we take a park, right? In a park, there's a child who kicks the ball. The ball initially was at rest, but once he kicked it, it starts rolling. If it is rolling, it will roll for a while and then it will come to rest, right? So we say that the ball was in motion for a particular duration of time. Suppose there is an old man sitting in the park bench and he's reading a newspaper. He has been reading the newspaper for the last half an hour, and we can conclude that he has not moved in that last half an hour. So he is at rest. This is how we broadly understand motion. But when it comes to physics, motion has to be defined. There are different aspects that we need to look into. There are different definitions that we need to understand first, and then we can truly understand motion. So, in today's class, we will be studying about motion. Under motion, there are some subtopics that we will cover. For example, first we'll understand what is motion. Then we will go on to understand the different types of motion. Then we will try to understand the state of motion, right? After that, we will try to understand kinematics and dynamics, right? And then we will cover kinematic variables. So, without wasting any time, let's move on to motion. Well, what is motion? Motion is defined as the change in position in a particular time duration with respect to a frame of reference. Now, mind you, there are three words that we need to keep in mind. The first one is change in position, the second one is in some time duration or time interval, and the third one is frame of reference. Now, I will make you understand this. Suppose there is a car which is at Patna 9 a.m. After that, it starts moving. It covers a distance of around 260 kilometer, and we can say that it does it in 6 hours, and it reaches Varanasi. So we can say that the car has changed its position. It was at 9 a.m. It was at Patna at 3 p.m. It reached Varanasi. So the time taken for it to cover 260 kilometers was around 6 hours, right? So we can say there was a change in position in some time duration, that is 6 hours, right? Now the third word, the frame of reference. Let's keep it for the coming topic. That means we will be studying relative motion, where we will understand what we mean by frame of reference. So this is what we mean by motion. Now you can take example of various things. right? A bird flying, a dog running in the park, right? When you throw a ball, it covers some distance, it takes some time, right? So this is all motion. Now we will study about the different types of motion. Under types, the first one is linear motion. The second one is circular motion. Third, rotatory motion. And the fourth one is oscillatory motion. Okay. Now, what we have to keep in mind here is the path, right? In linear motion, the path is in a straight line. That's why we say linear motion. Circular motion, the object moves in a circular path, similar to the earth revolving around the sun, right? Well, it is revolving in elliptical orbits, but we can understand this by this example that I have. Suppose this is an object tied to a string, right? I fix the length and I start rotating it. So the object here is covering circular path, right? That's why we say circular motion. Rotatory motion. Whenever an object rotates about its own axis, right? If an object rotates about its own axis, say this, if it starts rotating about its own axis, right? Then we say the object is undergoing rotatory motion. And oscillatory motion, a very cool example of oscillatory motion is the simple pendulum. Well, I have already arranged that for you. Let's take this. We have a string attached to an object, right? And what we do is, if the object, this is the main position of the object. Initially, the object is at rest, right? And suppose we apply some kind of force. The object starts oscillating about its mean position. It covers distances on both sides of the mean position, right? And this is a very simple example of oscillatory motion, right? So these are the four motions that we need to understand. After that, we will move on to our next topic. Well, the earth also undergoes circulatory motion and rotatory motion because earth revolves about its uh, orbit around the sun, and it rotates around about its axis, right? Now let's move on to the state, right? Well, if we were to understand, an object can undergo, or any body for that matter, it can undergo motion, or it may be at rest. But we have to be careful. When can we say an object is at motion? Whenever the object covers some kind of distance, or we can say there is a change in position in some time duration, right, with respect to a frame of reference. Now here I am going to explain you what we mean by frame of reference. Then we say that the object is in motion. Whereas when we talk about rest, the object has covered no distance, and we say the object has been in rest during that time interval, right? But motion and rest, when we are judging an object, whether they have been in motion or they were at rest, we have to always make sure that we understand what is the frame of reference. Now the frame of reference we can understand by this cool example. Suppose this is a bus, and there are two people who are sitting, right? And here we have a man who is standing, right? Suppose this is A, this is B, and this is B. We say that the bus was moving in the forward direction, right? Now let us take this instance. The bus or the vehicle has moved some distance, right? And C has not changed his position. So now, if A was looking at B, he would find that in that time duration, B has not changed his position because the distance between A and B has remained the same. If B turns around and looks at A, he will find out that A is sitting right behind him and he has not changed his position, right? So, what will A say? A will say that B is at rest, and B will say that A is at rest, right? But now if C was looking at A and B both, he will say that both, right? This is the observer, okay? This right here, this is the observer, I'm circling it. That A and B both are in motion. Well, that is quite confusing because when A was looking at B, B is at rest. And when B turns around and looks at A is at rest. So they should be at rest. But when C is looking at A and B both, he finds that their distance has changed. They were initially here and after some time they have moved ahead. So he will say that both A and B were in motion. Now it's quite confusing, right? This is where the term relative motion comes into picture, right? We try to understand motion with respect to an observer, right? And an observer is tied to the frame of reference, right? Here, the observer, in the third case, the observer is C, right? And this is his frame of reference, right? He's going to be looking at them from his point of view. And according to him, he will be able to judge, right? So motion is always relative. That is what we need to understand. You cannot judge. You have to first find out who is the observer. And once you clarify who is the observer, then you can judge what will be the motion. Whether there will be any kind of motion, whether the body will be at rest, right? For example, let us take this example. Suppose I am here right in front of you, right? And for you, I am standing in my position. I have not changed my position, so I am at rest. But for an astronaut who is in his space shuttle, right, he is looking at Earth, and the Earth is rotating about its axis. So every object on Earth is in motion for him, including me. So for him, I am in motion. But when you are looking at me, I have not moved, right? So according to you, I am at rest, right? So for this, we have to understand that motion is always a subjective aspect, right? We have to understand motion with respect to the frame of reference, or basically an observer who is observing the motion. Now, let us move on to the next thing. We are going to study about kinematics and dynamics. Well, they are very simple topics. What is kinematics? Suppose there is an object which is lying on a table. A force F is applied in this direction. The object has a mass m, right? After some time, because of the application of force F, the object moves and has covered some distance, right? Now, kinematics is the study of motion without considering into effect, the cause for motion, right? We are not going to look into the cause of motion, and the cause of motion here is force. We will not be looking at force, neither will we be looking at the mass of the object. We will only try to understand what was the change in position, the time taken for the change in position, what was the speed slash velocity, was there any kind of acceleration, right? And these things we are going to take into consideration and then try to understand the motion. Whereas when we talk about dynamics, we will take into consideration the cause for the motion. That is, we will think about force and its effect. That's what dynamics is. The study of motion by taking into consideration the cause of motion. Right? Now, these are the kinematic variables that I will be talking about in the next class. Now, let's recall what we have studied. What was motion? Motion is nothing but the change in position in some time duration with respect to a frame of reference or observer. What are the types of motion? You have circular motion, you have linear motion, you have rotatory motion, and you have oscillatory motion. Then, what are the different states of motion? Well, that is all relative. Whether an object is at rest or is it in motion, we can only judge once we have clarified that the frame of reference is clear in our mind. Right? Then we come to kinematics and dynamics. Well, kinematics and dynamics both are the study of motion, but in kinematics we do not take into consideration the cause for motion, whereas in dynamics we take into consideration the cause of motion. And the kinematic variables are basically you have time, you have change in position, displacement, you have speed, velocity, and acceleration. By studying these kinematic variables, we will be able to better understand motion, right? And in the next class, we will be continuing with our kinematic variables. We will define each of them. We will try to find the relation between them. And our first topic that we'll study will be distance and displacement. We'll try to understand the difference between them, and then we will proceed on to the next set of kinematic variables. Thank you, students. I hope you enjoyed the class today.